Welcome to the video on complex numbers. In the last video we talked about imaginary numbers and mentioned that to make an imaginary number all we need to do is take the square root of a negative number. For example, we might take the square root of -1, and so we take the square root of a negative number, which is an integer, and we get I, or an imaginary number. Well, we talked about playing with all these numbers, and we can keep playing with this. What if I took an imaginary number and I messed around with that? What if I added a real number, like 2, to an imaginary number, I? When you do this, you create a new group of numbers. This is not imaginary, it's not real, it's kind of a combination of both. We call that a complex number. So 2 plus I, it's a complex number. Complex numbers have two parts. They have one part or term that's real. A real number could be a positive or negative whole number. It could be an integer, irrational, or rational number. And then we have the imaginary part. So when you add real and imaginary numbers, you get complex numbers. You can even think about them in terms of a number line. In many school classes, we talk about number lines. And we have a number line, let's say I have 0 right here, and then 1, and then 2, and then 3, and then in this direction we have -1 and -2 and -3. Well, what happens if we go up or down on the number line? What happens if we leave the numbers? And not like a Cartesian plane where if we go up we have more numbers. Here we're saying, well, what if you actually left the group of numbers, or you went up or down? What would happen? Well, think of the x-axis here as your real plane, your real, not plane so much, but axes, and then this y-axis right here as your imaginary axis. So as we go up, we have I, and then so it's 1I, and then 2I, and then 3I, and then down here we have the opposite. We have -I, and then -2I, and -3I, and so forth. And the idea is that we can actually think about these complex numbers as points that are in these quadrants between the real and imaginary numbers. So right here we have 2 plus I. Well, it's 2 plus I, the number is right over here. That's our complex number, 2 plus I. So we can combine imaginary and real numbers, and we get complex numbers. And we should look at kind of operations with complex numbers. We'll start with addition. Adding complex numbers requires the same mindset as adding any variable group. So what we do is we add like parts, or like terms. So we add like terms. Oops, that's a K. Add like terms. So for example, if we had 30 plus 7I, and then we're adding that to 10 plus 4I, we add our like terms. The numbers 10 and 30 are our real numbers, so we add those, 30 plus 10, and we add that to our imaginary numbers, 7I plus 4I. So 30 plus 10 is 40, and then 7I plus 4I, think of this as just like 7x plus 4x. In both cases we have 7 i's, or 7 of something, plus 4 i's, or 4 of something, so we have 11 i's altogether. And you could write your answer just like that. Subtraction has a very similar idea to it. Let's say we had, if we're subtracting complex numbers, we just subtract like parts. So subtracting complex numbers, we subtract like parts. And let me just look at an example here, maybe with a negative. So if we had 100 plus 4I, and then we're subtracting from that 30 plus 10I, we can think about it like this almost, really. We're taking this term from here, so we're taking 10I from 4I, so 10I from 4I, and then we're taking 30 from 100. And we'll put those two together. So 100 minus 30 is going to be 70. 4 minus 10i is going to be negative 6i. And we're subtracting here, so in fact we have 70 minus 6i as our answer. Right, we subtracted those terms. 70 minus 6i is our answer. Multiplying, not much more complicated. When we're multiplying complex numbers, we just need to think about the distributive property. So multiplying complex numbers, think about the distributive property, which means you need to distribute every term. So make sure you multiply each term by the other terms. So you want to use the distributive property. So what does that look like? Well, let's say we had 6i plus 4 times 2i plus, 11. So when we just use the distributive property, we take these two terms and multiply them by these two terms over here. But the key difference is that we take 6i and multiply it by this term and the other term as well. We distribute it to both. So we have 6i times 2i plus 6i times 11. And then we take the 4 and distribute that. 4 times, so plus 4 times 2i, and then plus 4 times 11. And I'm going to simplify this a little bit. 4 times 11 is 44. 4 times 2i is 8i. 6i times 11 is 66i. And 6i times 2i is 12i squared. If you think back to our other videos, we talked about the value of I squared. The value of I squared is just negative 1. So this is 12 times negative 1 plus 66i plus 8i plus 44. And I'm running out of room, of course, but I'll go up here. 12 times negative 1 is negative 12. And we can combine 66i and 8i to get 74i, I believe. Yep, 74i plus 44. We keep going. I can combine 44 and negative 12 to get 32. So my final answer here would be 74i plus 32. And division is next, and I think division is the most difficult because it involves the idea of a conjugate. So what is a conjugate? What does that do? Well, let's look at a problem. Let's take, 5 plus 6i divided by 3 minus 6i. Okay. Actually, let's change this I up here. Let's fix that one. I just don't want to have the exact same value up here. I want to have something a little bit more complicated. So 5 plus, let's say, 10i. Well, what do we do? Well, 3 plus 6i, we want to manipulate that so we have real numbers down here, not the imaginary part. So we use the conjugate. Basically, a conjugate is an expression that uses the inverse operation in between its two terms. So if we have 3 minus 6i, the conjugate in this case would be 3 plus 6i. And we'll look at more detail on what conjugates are in other videos. So then, because we want to multiply both the numerator and denominator by the same value, think about this is kind of like a trick of multiplying by 1. As a simple example, if I had 2 over 4 and I wanted to multiply 4 by 3, well, if I want to keep my fraction the same, I have to also multiply the numerator by 3, and I would get 6 over 12, which is still just 2 over 4, or 1/2. As long as you multiply both the denominator and the numerator by the same value, you're not really changing anything. Same idea here. And let's see what happens. Well, what's going to happen now is we're going to actually get rid of the imaginary part of our denominator. So in our numerator, we use our rules for multiplication. 5 times 3, we're distributing, is 15. Plus 5 times 6i, which is 30i. Plus 10i times 3, which is another 30i. And then plus 60i squared. So in our denominator, we have 3 times 3, which is 9, plus 18i, 3 times 6i, and then minus 6i times 3 is minus 18i. So notice right there we're going to get rid of those i's. And then last we have minus 6i times plus 6i, which is a negative 36i squared. I'm going to combine like terms in my numerator, and I get 15 plus 60i plus 60i squared. And in the denominator, we have 9 minus 36 times negative 1. Going back, we had positive 18i minus 18i, that's 0. And I squared is negative square root of negative 1 times the square root of negative 1, which is just negative 1. So this becomes, now we have 15 plus 60i plus 60 times I squared, so that's, I'm going to go back actually, this is negative 1 here as well. So we can think of this not as plus 60, but as minus 60. So let me just erase that real quick. Make this a little bit easier on ourselves. So minus 60 all over 9 plus 36. 9 plus 36 is 45. And our denominator and our numerator, we can combine 15 and then minus 60, which is negative 40. So we have 60i minus 45, I believe. Right, because 15 minus 60, well, 15 minus 15 is 0, and then minus another 45 left, so it's negative 45. And we could stop here, but it would make more sense to keep going and simplifying this. You can think of this as 60i over 45 minus 45 over 45. So you want to separate, remember we're dealing with complex numbers, we want to have the part with the imaginary value and the part with the real value. And in this case we have something that cancels out nicely. 45 divided by 45 is just 1. So over here we could write this as 60i over, or 60 45ths I minus 1. But we can reduce 60 over 45, and I'm going to write that up here. And I realize, I hope you do too, that 15 is a common factor in both 45 and 60. So 60 divided by 15 is 4. I'm getting tired, but I think that's right, yeah, 4. And then 45 divided by 15 is 3. So it's 4/3 I minus 1. So see, that was certainly the toughest, was the division of two complex numbers. Again, this line here means division. Our first step was to multiply by the conjugate, and let me label this, we're doing division. Oops. We have division here. Multiply by the conjugate, that got rid of the i's in the denominator, right? And eventually we get 45 down here. And it also, in the numerator, leaves us with an I, but it leaves us with the complex number. We have the imaginary part and the real part, and then we could rewrite that as two fractions in two parts. Remember, our complex numbers have the imaginary part and the real part, and then we can reduce that, and eventually we got 4/3 I minus 1. And I think in the next video we'll look at the general cases of adding, subtracting, multiplying, and dividing complex numbers.